Hello friend, myself Sanjeev Divedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this conceptual video session on subject advanced algorithm. As the name suggests, advanced algorithm, it is advanced level of the subject that you studied in your semester 4. In semester 4, you studied analysis of algorithm. In semester 4, you studied analysis of algorithm. And in analysis of algorithm, you studied about time complexity and you studied approaches of solving a problem, be it divide and conquer, be it greedy approach, be it dynamic programming, be it branch and bound, etc. Now, what we studied in semester 4 to solve a given problem, which approach to employ so that we can get the best result. Correct? We also had a brief introduction on your last chapter, which was NP problems. Correct? We talked about NP class, we talked about NPC. Okay? So that was about analysis of algorithm. So this will be the prerequisite. This will be the prerequisite for the subject advanced algorithm. So in this semester, we are going to talk about many advanced topics, and the prior knowledge of analysis of algorithm will help you out in this semester. So here in this video, we are going to talk about module 1, that's fundamental of algorithm. The basic topic that we will be talking about is complexity and amortized analysis. Now we will see in detail what is. Now once you study this particular module, the outcome is you'll be in a position to analyze the different techniques of algorithm. Okay? This is what you will attain. The overall weightage of this particular topic in university question paper is around 15%. So it is very important exam point of view, and trust me, it's very simple. You just have to apply your brain, concentrate. Okay? So this is about the basic topics, course outcome and weightage of this chapter. The books that you are supposed to refer is Corman. Corman will be the best book to refer. However, you can also refer Horowitz, Sahani. That's fundamental of computer algorithm. Correct? So these are the book, and you must refer book. The content that I'll be taking in this particular video and many other video to follow will be from Corman. Okay? Fine. Now, to start with this topic, the first thing that we'll be talking about asymptotic analysis. Now, what is asymptotic analysis? In your semester 4, you studied techniques to find time complexity of an algorithm. Now, when it comes to time complexity of an algorithm, it is basic the running type of algorithm, and this running time was computed in terms of order of growth. Now, what was that? If the value of input n is increased by x, then what will be the time complexity? And by what amount the time complexity of the algorithm will increase by? And depending upon it, we had various different time complexities, like if. Now, remember one more thing. When I'm talking about asymptotic analysis, this analysis is performed for very large value of n. Large value of n, remember. So when it comes to time complexity, we are interested in finding the order of growth of the function. So if we say, you must have seen something like this, big O of n, we say it is linear order of growth. Big O of 1, we say constant order of growth, n square, we say quadratic order of growth, something log n, we say logarithmic order of growth. So these are various order of growth that we studied, and we are going to revise these concepts because it is expected in exam. Now, when it comes to asymptotic analysis, it is input bound. It depends on value of n. please. It depends on value of n. How my time complexity will vary if the input is varied. Okay, and depending upon these, we have the analysis to be done on three different cases: case, average case, and worst case. Now, when it comes to best case, it is the minimum time required by the program execution. Means for the given input, my algorithm will take minimum time. कम से कम time में execute होगा. So that will give the best case complexity. How do we represent the best case complexity? Using omega. Now, worst case complexity. For the given input, my algorithm is going to take maximum time. So it is the worst case. And how do we represent it? Using big O. Now, average case. Now, what is average case? If for the best case and the worst case of algorithm remains same, like you must have studied in bubble sort. In bubble sort, it was big O of n square and omega n square. Correct? So hence we can say the time complexity is theta of n square for bubble sort. Correct? So now remember this. When it comes to analyzing the time complexity, it is the maximum time taken by the algorithm to give you the result will be the worst case. The minimum time will be the best case, and if the maximum and minimum means for the input the maximum minimum remains the same, we'll say it is average case complexity of the algorithm. Let us see in detail these asymptotic notation, like the way we say big O, omega, and theta. Okay. Now big O notation. Now big O notation means what? See this, I mean how we have studied. F of n is big O of g of n. It means that f of n will be less than equal to some c times g of n for all value of n greater than n0, where n0 greater than equal to 1 and value of c is greater than 0. You understand this? It means that f of n is big O of g of n. Means the worst case for function f of n is g of n. Means f of n will always be less than g of n. Okay. It is used to represent the upper bound of the algorithm running time, and it always measures the worst case time complexity. Remember, here we have written this in another way. See, big O of f of n is g of n such that the c value is greater than 0 and some value n0 such that f of n is always less than equal to some c times g of n for all value of n which is greater than n0. So this is big O notation. I know you must have studied this. I'm just revising these concepts because it can be again expected here. Now, the next is omega notation. Omega gives us, so it is the formal way of expressing the lower bound of algorithm running time. And how we say f of n is omega of g of such that f of n is greater than some c times g of n, where c is greater than 0 and n value, and this condition will be true for all value of greater than n0 greater than equal to 1. Okay. So it means that for f of n will be, see, it means that g of n will be lower bound, means where maximum value of g of n is it can approach f of n, it cannot exceed. So f of n is always greater than some c times g of n. So it is the lower bound. So lower bound f of n is omega g of n, means lower bound is g of n. So g of n will always be less than f of n. If you can see, it will always follow f of n. So this gives me the best case complexity. And theta gives me average case complexity. Now when it comes to average case, it can be used to express lower bound as well as upper bound of an algorithm running time. And how do we represent it? It is represented something like this. F of n is theta of g of n such that we have f of n. See, f of n will be greater than equal to some c1 g of n less than equal to some c2 g of n, where n greater than equal to n0 and n0 greater than 1. ठीक है, n greater than n0 and a value of n0 should be greater than equal to 1, and c1 and c2 are positive constant, that is greater than 0. Now this is very complicated in terms of mathematical representation. What you are supposed to understand is this: if f of n is, let's say, if f of n is omega of n, yani the best case is n. If f of n is big O of n, means if the worst case and best case is same, it is linear, the best case and worst case for the function is linear, then we can say the f of n is theta of n. So that's the average case complexity of the algorithm, correct? So this is, so we have discussed about these. Now let us see another example. Okay. Now, in this example, I've been asked to find the upper and lower bound. So the function is 4n square plus 5n plus 3. Now I want to find the upper bound. Now the highest order is n. So let's say g of n is n square as mentioned here. G of n is n square, correct? Now since this will be the upper bound, so what we'll have, f of n is big O of n square, consider, because the highest order is n square, it is quadratic. So we will say, let's say the upper bound is big O of n square. So by definition what we will have, f of n is less than equal to some c time n square. ठीक है, what is f of n? F of n is 4n square plus 5n plus 3. So what we have, 4n square plus 5n plus 3 less than equal to some c time n square. Now what we are supposed to find is, we are supposed to find two things. We are supposed to find value of c which is greater than 0 and a value of n, ठीक है, such that it should be equal to n0. I want that initial value for which this condition is true. I want n0 and value of c for which this condition will be true. So you can, I mean, you can take with any value of c, depends on you. I have taken the value of c as 5. Again, it's my choice. Any positive constant. ठीक है, so what we have, let us say 4n square plus 5n plus 3 less than equal to 5n square. Now we will start with value of n with 1, n2, n3, n4, n5, n6. Now the moment when value of n is 6, then this condition will be true for first time. Then this condition will be true for first time. So we can say this is true for value of n greater than equal to 6. This 6 is nothing but n0. So we have a value of c, we have a value of n0 for which this condition is true. So we can say the upper bound is n square, correct? So now let's find lower bound. So again the highest order is n square, so we'll say let g of n be n square. So now if we have f of n is omega n square, okay, then this f should be greater than equal to c time n square. Again we need to find value of c and n0 that will satisfy this. Let us say value of c is 3. So what we have, 3n square less than, I mean it depends, you may write something like this. You may write f of n greater than equal to c times g of n, or you may write c times g of n less than equal to f of n. It's one and the same. This is what we have. And if we see the first value of n for which this condition is true is 1. So we could find the value of c and n0 for which this condition is true. So we can say f of n is omega of n square. So in this way we were able to find the lower bound and upper bound for the given function. So this was about in this particular video. Thank you very much.